Okay, so just looking at this here, so sketch the line that passes through 2 points given the following question and hence find the equation. So if I've got these 2 points, the first thing you find in the equation is you have to find the gradient. Now to get the gradient's y2 minus y1 on x2 minus x1. So it's the difference in the x's over the difference in the y's over the difference in the x's. So this point here is 2, 2, and this one here is minus 2, minus 4. So it's going to be 2 minus minus 4 over 2 minus minus 2. So that would be 6 on 4, which is 3 on 2. So that's the gradient, 3 on 2. And then the equation, you need a point, which is 2, 2. So you go y minus y1, this is the formula for it, x minus x1. So it's y minus 2 equals 3 on 2, x minus 2. And you could use the other point too. You'll get the same answer if you use the other point, minus 2 minus 4. So if you multiply that over to the other side, equals 3, x minus 2. And then just expand the bracket. 2y minus 4 is 3x minus 6. I like to bring it all to the one side. So it's 3x minus 2y minus 6 plus 4 equals 0. This is called general form. So 3x minus 2y minus 2 equals 0. So I know they use it doing the y-intercept, but you can just use this formula. I think this formula is a more efficient way of doing it. The gradient there is 1 because you minus 1. You may not always have the y-intercept. So that would have been using y equals mx plus c. So y equals 3 on 2x minus 1. Okay, so if we look at the next one, you've got minus 3, 4 as a point, and you have 3 minus 2 as a point. So the gradient is y2 minus y1 on x2 minus x1. So it's minus 2 minus 4 on 3 minus minus 3. So you get minus 6 on 6, which is minus 1. So you have gradient, and all you need is 1 point, and then you just use this formula. X minus x1, so you go y minus y1, I'm just using this point as my first point. You could use either, equals minus m, which is the gradient, x minus minus 3. Okay, so you get y minus 4 equals minus x plus 3. So y minus 4 equals minus x minus 3. And then equals minus x minus 3 plus 4. So minus x plus 1. So, so looking at this then, if we get the gradient, this is minus 6, 6, and this is 4 minus 4. So the gradient, you could do rise over run, but we want a more efficient method. Minus 4 minus 6 over 4 minus minus 6, because first you subtract the y values, and then you subtract the x values. So, yeah. So that will be minus 10 on 10, which is minus 1. Now you could simply just go that's y equals mx plus c. You could get it from the diagram, and I think that's all that they really want you to be able to do here. So y equals minus x. But if we use the equation that I taught you, y minus y1 equals mx minus x1, then it's y minus y1. Now I'm going to use this point, 4 minus 4. So y minus minus 4 equals minus 1 x minus 4. And then if you simplify that, that's y plus 4 equals minus x plus 4. The plus 4's go out, and you just get y equals minus x. Looking at this one, same thing. You're best use the formula now for the gradient, because you'll get the right sign. Can you see? So this is 6. And 6, and this is minus 4 minus 8. So the gradient is y2 minus y1 on x2 minus x1. So that's 6 minus minus 8 on 6 minus minus 4. 6 minus minus 8 is 14. 6 minus minus 4 is 10. So you end up with 7 over 10. Now, the actual, you could just draw this and then see how it's hard to read the point for the y-intercept, but I think it's minus 2. But we're just going to use our formula. So So you go like that. So it's y minus y1. Now I'm just going to I might take 6 equals 7 over, so it's 7/5, 7 over 5, x minus 6. Because 14 on 10 simplifies to 7 on 5. Now, I do have a way that I actually like you to, you bring that up there. So therefore that would be 5y. I like to bring that up there. See how it's times 5? You move it to the other side and you get times it on the other side. It just makes for a neater equation. Then that would be 5y minus 30 equals 7x minus 42. And then if you bring it all, I like to bring it all to the one side. So it's 7x minus 5y minus 42 plus 30. Which is 7x minus 5y minus 12 equals 0. So the way that they've done it is they've read off the y-intercept, and they've got it like as minus 1.4. There is no way you're going to be able to get it as minus 1.4. I just want to show you that if I do put this into, bring the 5y on that side, and then divide by 5, then you actually get the accurate y-intercept. So you can see the gradient is 7 on 5, and where it cuts the y-axis would be minus 12 on 5, because that part there is your weight, and this part, the other part, the one in front of the x, remember, is your gradient.